All right, we've already looked at 3 examples of how we can compare slopes and y-intercepts of different functions. I'd like to give you a few more examples of a few different kinds in case you need some help referring to some others. This one's particularly weird because if we read it, I'm comparing the functions f of x, which is graphed below, and we're comparing y-intercepts to the function where g of x equals 5 times 2 to the x power. This is not linear. This is what we call an exponential function because we have our x in the exponent. We'll learn loads of this more later, but for now, all we need to be able to do is to evaluate it. We know that when we're talking about y-intercepts, on the y-intercept, this is always where your x is 0. X cannot be to the left or to the right because it has to be dead center on the y-axis. So we know something. Let's go ahead and put a note. Your y-intercept means x will be 0. So I'm going to add that as my left side question. What is the value for x for any y-intercept? Okay, so back to my problem. If I'm asking about y-intercept, that means that my x for this formula and my x for this graph are going to be 0. So I could go ahead and find g of 0 to the 0 power. And I can evaluate that. Exponents first, 2 to the 0 power is 1. So really g of 0 is 5, meaning that my y-intercept is 5. And over here I can see my y-intercept is -1. So if I'm saying, if I look back, it says, what is the sum, keyword, of the y-intercepts? Sum tells me to add them. So I'm going to go ahead and just say, no big deal, 5 plus -1. It's kind of like 5 take away 1 would be 4. All right, careful. There's a lot of tricks in that one. Feel free to pause, go back, rewatch, stop it, take your notes, then play, however you want to go through with it. Here's some more wordy examples, but really they're the same thing. Let's go ahead and see what's happening. Simone wants to rent a car, and he's comparing rates from Rent-A-Car and Enterprise. Rent-A-Car can be using this function here, where R of M is a total cost to drive and M is the miles. The rates for Enterprise is in this table, so I'm going to label that Enterprise, and that one's R for Rent-A-Car. The rates for, which of the following statements is true? If I look at this, they're all talking about cost per mile, cost per mile, cost per mile, cost per mile. So I have to ask myself, is that the rate of change or the initial value? Well, cost per mile is how much it would change every mile that I drive. So that's my rate of change or my slope. So I'm really just trying to figure out the slopes between the two. Well, this one, to get from 67 to 74, I know that it's going up, and it's going up by $7, and we're going up by 100 miles. So my rise over my run is $7 per every 100 miles, which when I simplify that is 7 cents per mile. 7 cents per mile. And over here, my rate of change is my slope, which is the number multiplied to my x normally, but in this case we're using m for miles instead of x. So 4 cents per mile or 7 cents per mile. Let's see which one of those are true. I can get rid of these right away. Rent-A-Car has a greater cost at 4 cents per mile. Well, it is 4 cents per mile, but is 4 cents greater than 7 cents? I don't think that's true. How about this one? Enterprise has a greater cost per mile at 7 cents. Yes, 7 cents is greater, so we'll go ahead and go with that one. That's actually not that bad. The hardest part is reading it and figuring out what are they asking me for. So let's go here and see about this one. Similar situation, except we're talking about electricians this time. Zappies can be used with this function. C of H is the cost, H is the hours, and lights on as my table right here. And I want to find out which is true. If I look at my choices, I see initial cost, initial cost, initial cost. So I know that they're asking me in this one for the y-intercept. Whereas the one above, this one was asking me for my rate of change or my slope. All right, so in that case, I have a little bit more work because I have to find the next step to find the y-intercept. When I look here, it's kind of in slope-intercept form, which is nice. Y equals, mx. I don't see mx here, but I do see mx here, in this case h instead of x. So I know that 35 was my y-intercept. Okay, great. So right away I know that Zappy's is not 35, so I can cross that first one out. And over here I want to look for my y-intercept. So I'm talking about cost per hour. So cost per hour would be my change in cost over my change in hour. So I can see that I'm just picking these 2 points. You really could have picked any ones that you wanted. But if I look from 79 to 92, I can see that it's going $13 up per every hour. You could also use linear regression on this one. I'm choosing to do it out, but you may use linear regression on this if you so choose. So if I write out my formula, that's y equals 13 over 1, which is 13, x plus b. And I'm going to choose any of these points to put in for my x. This is my x, this is my y. Which one looks easiest to me? I'm going to go with this one, so I have a 1 in there. My y value, 53 equals 13 times 1 plus b. 53 equals 13 plus b. Let's try to get this b alone so I could figure out my y-intercept. My y-intercept is 40. So I have a y-intercept of 40 and 35. So which one's true? Well, which one's greater? This one's greater. So lights on has a greater initial cost of 40. True, because this is true, but it's not greater. This is the least value. All right, that's plenty of examples. Feel free to go back as many times as you need. I gave you hints on your classwork, so you could see which examples might be good to look at for each problem. Just like yesterday, you have this classwork. Any that you do not finish are homework. If you finish them all, you have no homework. So have a wonderful Friday. I look forward to collecting all of your work and seeing how wonderful you did on Monday when I return. Have a great weekend.